Hello, this lesson is about using the quadratic formula to solve quadratic equations. So the formula to solve a quadratic equation is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And you fill in the a and the b and the c from your original equation. A is the number in front of the x squared. B is the number in front of the x. C is the constant. Now, before we use the formula to solve the equations, we're going to look at just one part of the formula, the part that is underneath the square root, not including the square root, just the part underneath. And that part is called the discriminant. And we can use this to figure out how many solutions our equation is going to have. So if it says find the discriminant and name the number of solutions, and just a reminder, other words that mean solutions are roots and zeros. These are all telling us the values that we could plug in for x to make the equation true, or when we graph it, that's where it crosses the x-axis. So let's label our coefficients, our a, b, and c. In front of x squared, there's this invisible 1. So a is negative 1. B is the coefficient of the x to the first power. And then c is the constant. So to do the discriminant, we're only filling in b squared minus 4ac. When we do that, we would have 4 squared minus 4 times negative 1 times negative 4. And that comes out to be 0. Now, how does that tell us how many solutions we have? So if we look at the graph of this, negative x squared plus 4x minus 4, we can see that the vertex is sitting on the x-axis. So there's just one solution, and that will always be true. If your discriminant is equal to 0, that means there is just one real solution. So discriminant equal to 0 is one real solution. Let's look at another one. Okay, again, we're just going to do the discriminant. And our a value is 1, b is negative 6, c is 11. Negative 6 squared minus 4 times 1 times 11. When you are squaring a negative, make sure that you include the negative in the squaring. Negative 6 squared is negative 6 times negative 6, which is positive 36. But if you put it in your calculator like that, your calculator is going to give you negative 36 because you didn't tell it to include the negative. So if you want to square a negative in your calculator, make sure you put a parentheses around the negative number and then square it. So negative 6 squared minus 4 times 1 times 11 gives me negative 8. Okay, what does that tell me about the number of solutions? Let's graph and see what this looks like. It is x squared minus 6x plus 11. So we can see that the parabola never crosses the x-axis. So there are no real solutions. My discriminant came out negative, and there were no real solutions. So that will always happen. If your discriminant is less than 0, which means it's negative, then you know your parabola is never crossing the x-axis and there are no real solutions. There are imaginary solutions, which is an Algebra 2 concept that you'll get to. Okay, let's look at another one. Again, we're just doing the discriminant. And our A value is 2. Our B value is 3. There is no C value. So the C value would be 0. Filling into the discriminant would be 3 squared minus 4 times 2 times 0, which would be 9. So let's see what our solution situation is for this. 2x squared plus 3x. And it crosses 2 times, 2 solutions, which is what you'll have most of the time. So this time our discriminant was positive. We got a value bigger than 0. And when that happens, you will always have 2 real solutions. Now, when you're doing the discriminant and figuring out the number of solutions, there's no need to graph it. Once you do the discriminant and you get your answer, that will be enough to tell you how many solutions. So let's go back and look at what we have. If your discriminant is positive, you'll have 2 real solutions. If your discriminant is negative, you will have no real solutions. And if your discriminant is 0, you'll have 1 real solution. Now let's use our quadratic formula to actually find out what those solutions are. When it's crossing the x-axis, what are those values? What values will make our equation actually equal 0? And we need to always make sure we equal 0 before we start. So our A value is 1, B is 4, C is negative 2, and we'll plug into the formula. There's a negative in the formula, plugging in a 4, plus or minus square root 4 squared minus 4 times 1 times negative 2, all over 2 times 1. Then that would be negative 4 plus or minus square root. And if you calculate the part under the square root, don't push the square root button, it comes out to be 24. "24 is not a perfect square, but we can break that down and simplify it, make a little factor tree. "24 is 4 times 6. You could do lots of different things there. 4 is 2 times 2, and 6 is 2 times 3. So whenever you have 2 of the same number, that number can come out of the house. No friends, have to stay home. The 2 and the 3 stays home. So now we've got x equals negative 4 plus or minus. The 2 came out of the house. Staying home is the 2 times 3, which is 6. Then there's one more step. If all 3 outside numbers divide by something, you have to reduce it down. So negative 4, 2, and 2 all divide by 2. So when I divide those all by 2, I would get negative 2 plus or minus square root of 6 all over 1, which you don't have to write. So those are the 2 solutions. Those are the 2 places it crosses the x-axis. One answer uses the plus, and the other uses the minus there in the middle. And you can see also, if you think about the discriminant, it was 24, that's positive, and that told us ahead of time that we should have 2 real solutions. This problem is not quite ready in standard form. We want it to equal 0, so we have to add that 2 over to the left side. 2x squared plus 4x plus 2 equals 0. So A is 2, B is 4, C is 2. Filling into the formula, negative B plus or minus the square root of B squared minus 4AC all over 2A. Underneath the square root, the discriminant, we would have 0. Okay, so the discriminant is 0. That tells us that there's just one real solution. And that's because if you do the square root of 0, it's just 0. And it doesn't matter if we add 0 or subtract 0, we're going to get the same thing. So it's just crossing the x-axis, or touching it really, at negative 1. So that means just the vertex is sitting on the x-axis. And I knew it was a right side up smiley parabola because my a value was positive. So one solution, if your discriminant is 0, x equals negative 1. You can always check this solution. You can take the negative 1, plug it back in for all the x's, make sure it comes out to be 0. For the next one, again, it's not quite in the right form, so we need to add the 3x to both sides. We need to add the 6 to both sides so that it all equals 0. 2x squared plus 3x plus 6 equals 0. And then we have a is 2, b is 3, c is 6. X equals negative 3 plus or minus the square root 3 squared minus 4 times 2 times 6 all over 2 times 2. Then calculating the discriminant, the part underneath the square root, we get negative 39. If you try to do square root of a negative number on your calculator, you get an error. And remember from looking at our discriminants, if it's negative, then there's no real solution. So you can stop right there and say no real solution. There's still a parabola, but it's just floating. It's not ever going to cross the x-axis. Okay. This one is also not in the right form. We need to move the x over, and it will join up with this negative 5x. And we also need to subtract the 4. So our equation should be 3x squared minus 6x minus 4. Filling into the formula, there's already a negative in front of the b. And then our b for this problem is also negative, so the negative negative will turn it positive. Of b squared minus 4ac all over 2a. And so underneath the square root, we get 84. And 84 is not a perfect square. We need to break that down. Let's see, 84 is even, so I know it divides by 2. Same thing for 42. And then 21 is 3 and 7. So I have two 2's, they're friends, so a 2 can come out of the house, but the 3 and the 7 will have to stay home and get multiplied back together. X equals 6 plus or minus the 2 comes out of the house. 3 times 7 stays home. And again, look at all three outside numbers. They all divide by 2. So we reduce that down, dividing by 2. And those are two solutions. We knew we were going to have two real solutions because our discriminant was positive. So that parabola will cross the x-axis 2 times. And then lastly, I don't have the whole problem for this, but suppose you're working through your problem. We've worked, and now we're to here. And we have x equals -3 plus or minus the square root of 25 over 6. It doesn't matter. So I wanted to show you what happens if your discriminant is a perfect square. 25 is a perfect square. The square root is 5. So if you end up with a situation like this with a perfect square, and so you take the square root just goes away, you need to go ahead and write it twice, once with the plus and once with the minus. So you would have -3 plus 5 all over 6 and -3 minus 5 all over 6. -3 plus 5 would be 2/6, reduces down to 1/3. And then -8 over 6 would reduce down to -4/3. So if your discriminant is a perfect square and it comes out, go ahead and write it two times, once with the plus and once with the minus. And so that would be another situation where your